Hi everyone, my name is Dior, and I approach this problem as a system of linear equations, and that's kind of when you have multiple equations that are related to one another. So um, if one equation is satisfied, it has to also work for the other ones. And in this case, we kind of had that going on. So that's how I chose to approach it. So we knew that the sum of coins between nickels and dimes had to equal 27. So not the value of them, but the actual amount of nickels and dimes had to total 27. So that's the first system here that I wrote. N plus D equals 27. And I wrote here that dimes are going to equal D and nickels are going to equal N. It's just a shorthand just to make the equations a lot less wordy. The second system is including the actual value of each coin because we know that the collection of both coins have to equal $1.75. So we know the value of a nickel is 5 cents and the value of a dime is 10 cents. We could have just used fives and tens and then converted it back, but I just chose to use their actual value just to stay consistent. So that is what the second part is, 0.05 n plus 0.10 d equals 1.75. Again, that's just because of the values of the nickels and dimes. So the purpose when you set system like a system of linear equations up, you try to cancel out a couple terms just so you can isolate one, find the value of that, and then once you have that value, you plug it back into the original one and try to find the other term. So that's kind of what I did here. So I started with multiplying the top term by negative 0.05 because we need them to cancel. So if they're the same sign, they won't cancel out, they'll just add on to each other. So since that was the smallest term, I just chose to go with that one. And so when that happens, you have to apply that to each term. You have to distribute all the way over. So that's why this first term here, I know it's crossed out because I already did the math, but the first term here is negative 0.05n minus negative 0.05d. And finally, 27 times 0.05 is 1.35. So we have that set up. So this cancels out, and then we're left with 0.05D is equal to 0.40 because when you do the math, negative 1.35 plus 1.75 is equal to 0.40. Yes. So then you still have to isolate this D here. So you have to divide both sides by 0.05, and then that gets you 8. So we would know that, so by knowing what the value of dimes is, we can plug, that's what this arrow is. Sorry if it looks confusing because I just kind of wanted to bring it back to the original equation. So by knowing the value of D, we can now try and isolate to find N. So the original equation, I just used the top one just for simplicity, is N plus D equals 27. Again, that relates to the sum of the coins themselves have to equal 27. So if we found D, we just plug that in. So now we have N plus 8 equals 27. You subtract both sides by 8, and then you're left with N equals 19. So there's 19 nickels and 8 dimes. The way to check to make sure, even though this worked out fine, it's always good to just do a double check. So I plugged the numbers back into the second equation just to make sure. So that's what this check is here for right here. So wherever you see an N or a D, you plug it in with their actual value. So N is 19 and D is 8. So wherever you see an N, you plug in 19. Wherever you see a D, you plug in 8. And so that's how we get here 0.0519 plus 0.108 equals 1.75. And then you actually do the math. 0.05 times 19 is 95 cents or 0.95 plus 80 cents or 0.80 equals 1.75. So we know that our values for D and N are correct because they plug and worked correctly in both systems. So I hope this helps.